Hello friends, today we are starting with our topic, that is periodic functions. What are the periodic functions? Periodic functions, let fx is a function and f of x plus t is equals to f of x for t is greater than 0. If we are taking t which is greater than 0 and f of x plus t becomes f of x, then fx is said to be periodic with time t. It means, suppose we are taking fx is equals to sine x, and we know f of x plus 2 pi, that is this, which is equals to sine x again, right? Simply f of x plus 4 pi is equals to sine of 4 pi plus x, that becomes sine of x. Similarly, f of x plus 6 pi is equals to sine of 6 pi plus x, that is sine x. What does it mean? It means there are the periods like 2 pi, 4 pi, 6 pi, all can be considered as the periods for the given function sin x. Okay? So suppose we are discussing about the periods. So there are 2 pi, 4 pi, 6 pi, 8 pi, and so on. But 2 pi is the fundamental period. Fundamental period for sin x. So here we are talking about the fundamental period. What is a fundamental period? It is a minimum, or you can see the smallest period by which fx follows the criteria f of x plus t is equals to fx for t greater than 0. Then this function is said to be periodic function with the period 2 pi. We can take the period 2 pi, 4 pi, 6 pi, 8 pi, but you have to take the fundamental period as 2 pi. So we are discussing about the fundamental period of every function. Similarly, or you can say in the graph, we have, whenever you take the graph of this, so it is 0, this is pi, this is 2 pi, and here it is 3 pi, and then you have to increase it by 4 pi. And similarly, we can go on the left hand side also, that is minus pi, minus 2 pi, and so on. Then this graph, which is moving from 0 to 2 pi, basically this graph is repeating again and again when you will fold it from x is equals to 2 pi, right? So this curve will move again and again for the interval from again 0 to 2 pi, then 2 pi to 4 pi, 4 pi to 6 pi, and so on. So this is called the fundamental period. 2 pi is called fundamental period because within the interval of 0 to 2 pi, the period again and again, the values of the given function will be same, which are lying between minus 1 and 1. So it is called fundamental period of sin x. Similarly, you can take the fundamental period of cos x also. Cos x also have the same fundamental period, that is 2 pi. If fx is equals to sin x is periodic function with the value of t is 2 pi, then f of 4x means that is sine of 4x. What is the period of this function? So its period will be, that is 2 pi upon 4. Just see the multiple of x. It is 4. So you have to divide the fundamental period by 4. Then we get the period of this function, that is pi upon 2. In a similar way, if we are talking about the period of sine of x upon 4, what will be the period of this time? This function, you can say that is 2 pi upon 1 upon 4. What is the coefficient of x? That is 1 upon 4. So dividing the fundamental period by 1 upon 4, that will be 8 pi. In this way, we can find out the period of any function if we know the basic period of the basic function, right? So period of the basic function sin x is 2 pi. So we can find out the period of the other functions whenever any number is multiplying with x, or any number is divisible by x. Or you can say if fx is periodic with period t, then f of ax plus b is periodic with t upon a. The period will be t upon a. If we have this kind of function, suppose we have a into x plus b upon a plus b. In this way, we have any function, then it is also periodic with the same period t upon a. It means the main thing is what is a coefficient of x. So you must divide the given period, fundamental period, by that constant which is with the t with x. It means the coefficient of x, say you have to divide the complete t with that value. Then we obtain the period of that function. Suppose we want to find out the period of sine of 4x plus 3 plus 5. There is no problem. Just you have to take this one, 4. What is the coefficient of x? That is 4. If the coefficient of x is 4, then time period will be, what is the fundamental period of sine? That is 2 pi. Then dividing it by 4, we obtain pi upon 2. So it will be the fundamental period for this function. So if the coefficient of x is 4, you have to dividing the fundamental period with 4, we get the periodic time. So in this way, if we know the period of the basic function, then we can find out the period of the other functions which are associated with the basic function. Now, if fx and gx are the functions with periods, that is t and t dash respectively, then period of fx plus minus gx, or fx into gx, or fx upon gx, these all functions has the periodic time which is the LCM of t and t dash. Means if two functions are there, whether they are connected with plus sign, minus sign, multiplied or division sign, then the LCM of t and t dash, right? So that shows the periodic time for these kind of functions. Suppose we are taking the periodic time, find the periodic time for sin x by 3 plus cos x by 4. Find the periodic time for this function. So here, first of all, what is the periodic time for? PT is a short form for periodic time. What is the periodic time for sine of x upon 3? Just you have to dividing the fundamental period of sine by 1 upon 3. We obtain 6 pi. Now, periodic time for cos of x upon 4. That shows 2 pi upon 1 upon 4. That will be 8 pi. Now, take the table for this, right? So, periodic times for first function, periodic time for fx. Suppose I am taking fx as sine of x by 3, and its period 6 pi, and that is 12 pi, and 18 pi, and 24 pi, and so on. And periodic time for another function gx, where gx function is our second function, that is 8 pi, and take the multiples of 8, 16 pi, 24 pi, 32 pi, and so on. So which are common between them? Which are common between them? These are 24 pi, right? So 24 pi is the LCM of 6 pi and 8 pi, right? LCM of 6 pi and 8 pi, what is 24 pi? So we can say the periodic time for sine of x upon 3 plus cos of x upon 4 is 24 pi. In this way, If there is division sign, there is multiplication sign or minus sign, then the periodic time will be same in all the cases, right? So you have to take the periodic time of fx plus minus gx, fx into gx, fx upon gx by the LCM of t and t dash. And it is very important as for the entrance point of view. How we can find out the period for suppose there are two kind of functions, one is periodic and another is non-periodic. So what will happen? Suppose px is periodic and nx is a non-periodic function. Non-periodic function. What will happen if we take the composition of both? Periodic of non-periodic function. What will happen? If you take periodic of non-periodic, then it is always non-periodic function. And if we take non-periodic of periodic, is always periodic function. And it is also very important result. Suppose, for example, we have periodic function as cos x, right? And non-periodic function as x square. If you are taking p of nx, what does it mean? You are taking cos of x square. So p of nx will be non-periodic, because here x square is non-periodic. We know the graph of x square, which is non-repeating graph, right? So nx is a non-periodic function. So p of nx will be cos of x square. It is a non-periodic. And in this way, n of px means you can take that is cos of x square, that is periodic in nature. Periodic function. So in this way, we can apply this result. If px is periodic and nx is non-periodic function, then the composition of these two functions will give the different results. As we know, f of gx is not equals to g of fx, so their behavior may be different. So p of nx is non-periodic in nature and n of px is periodic in nature, and we can develop the period by the same formulation as we have discussed in our previous example, right? So in this way, we can discuss the nature of the periodic function. And one more thing is, in our daily life, we can see the periodic functions by your heartbeat, right? So heartbeat is always pumped up after some regular time of interval. And second is phases of moon. You can see phases of moon is also an example of the periodic function. And there is another, like you can take the seasons. So in the seasons, we have after the regular time of interval, the season will change. And electromagnetic waves, electric waves, AC current waves. So all are the expressions given in the form of sin x and cos x basically. Why? Because function every function which is like algebraic function, suppose x square is there, x cube is there. So with the help of Fourier series, we can convert the given functions in terms of sine and cos. So most of the functions are studied with the help of sin x and cos x in terms of periodic functions. So whenever you find out the nature of the function, periodic function, period of the function, then you can take any function into the format of sine and cos. You have to convert the given function into the format of sine and cos, and then we can apply these kind of concepts to find out the period of the function, right? So in our next video, we will take some other topic, that is our inverse of the function, which is the last topic of the function we will discuss. And now we are going and meet you soon in our next video. Thank you. Have a nice day.